Hello grade 11s. We're now going to go on to inclination of a straight line applications. We're still working with the slides Analytical Geometry and we'll be going from slides 47 to 52. So the first example says, determine the equation of a line through the point A 3 minus 4 and it has an inclination of 45 degrees. Now, because it's a straight line, we know that the general equation for a straight line is y is equal to mx plus c. You have two unknowns here that you need to solve for. We need to solve for the m and for the c. Now, the first thing that we're going to solve for is for the m. Now, we know from the previous video that m is equal to tan theta. Now we know what our angle of inclination is. It's 45. So m is equal to tan 45. You can just put that right into your calculator. Tan 45 equals, and you get m is equal to 1. So now, with this equation over here, we get y is equal to 1x plus c. You don't have to put the 1 there. I've just put the 1 there just to show you where it goes. Now, in order to find the c value, you substitute this point into the x and into the y of this equation. Remember that this is your x value and this is your y value. So our y is minus 4 equals our x is 3 plus c. So minus 4 is equal to 3 plus c. Take the 3 to the other side, it becomes a minus, and you get c is equal to minus 7. Therefore, the equation of this line is y is equal to x minus 7. Moving on to example 2. So, example 2 says, determine the angle BAC. BAC. So they want this angle over here. The angle formed by the lines AB and AC. So this is the unknown that we want here. They've given us that as alpha and that as beta. So what I'm going to do is I'm going to call this angle theta. Now, what I want you to notice here, grade 11s, is we have a triangle over here. And what is so special about that triangle? If we can solve for alpha and solve for beta, we can solve for theta, because exterior angle of a triangle is equal to the sum of the interior opposite angles. So let's do that. Let's calculate out what alpha is first. So we know that tan of alpha will be equal to the gradient of this line over here, which is AB. So tan alpha will be equal to y2 minus y1 over x2 minus x1. This can be our first point, that can be our second point. So y2 is 0 minus our y1, which is 3, over our x2 is going to be 2. I lied to you. Our x2 is going to be minus 1 minus our x1, which is going to be 2. If we work that out, we get minus 3 over minus 3. So tan alpha is equal to 1. In order to work out that alpha, we go shift tan of 1. And we get alpha is equal to 45. Now, in order to work out beta, beta is going to be the angle of inclination for this gradient AC. So tan beta is equal to the gradient of AC. So tan beta is equal to y2 minus y1 over x2 minus x1. So equals, this can be our first point and our second point. So y2 will be minus 3 minus y1, which is 3, over x2 is 5 minus our x1, which is 2. If we work this out, minus 3 is minus 6 over 5 minus 2 is 3. So we get tan beta is equal to minus 2. In order to work out what beta is, you go shift tan minus 2, and you're getting negative 63,4. Now remember, grade 11s, if you get a negative angle, add 180 to it. So negative 63.4 plus 180. And we get beta is equal to 116,6 degrees. Right, so we have these two angles now, alpha and beta. Now, we know that beta, or let's rather do it this way, we know that theta plus alpha will be equal to beta. The interior angles are equal to the sum of them are equal to the exterior angles. So, exterior angle of triangle. So, theta plus our alpha, which is 45, equals our beta, which is 116,6 degrees. That means that theta is equal to 116.6 minus 45. And we get 71,6 degrees. And that's the angle that they wanted. Grade 11s, I would like you to do exercise 4.5, number 3 to 5, please. And then exercise 4.6. And that's that. Thank you, grade 11s.